the third installment of the Kurz Industrial Solutions Wind Division podcast. We have Neel Sheth from Merson USA. Neel is the Wind Power Applications Manager at Merson USA. Obviously, Merson is a global expert in electrical power and advanced materials. Merson designs innovative solutions to address its clients' specific needs and enable them to optimize their operations. They have over 6,900 employees operating in 35 countries and provide purpose-designed solutions bespoke to customer requirements anywhere on the planet. Neel, that's a pretty big introduction, I would say. Obviously, the reputation of the company speaks for itself. Firstly, thanks for coming on this show here, and we really do appreciate the time.
No, thanks for having me, and it's a great initiative you have there, Dan, and always here to help.
Yeah, absolutely. So Neel, we've got a list of questions here. We're going to let it kind of free flow, so feel free to add in or chime in anything that you like. But we're going to dive right into it. So Neel, I would imagine you weren't, 5 years old telling your parents you wanted to be a wind power engineer. Maybe you're the anomaly here. I'm not 100% sure, but I certainly didn't think I'd be in the industry even just 5 years ago. But I'd love for you to take me through some of your background and how you ended up working at a company like Merson USA, and what decisions eventually led you to be in this awesome role that you're in today.
So it's been an interesting journey so far. Actually, I'm an aerospace engineer. Started off with a bachelor's in aerospace from Russia, and wanted to do something offbeat. So ended up in a school there in Russia, of all the places. Super cold, as I found out when I went there, but after that, my focus back then was mostly satellite design and upper stage rockets, but then I decided to go for a master's degree and then ended up at Penn State, which actually focuses quite a bit on wind energy in their aerospace department. So that was my foray into wind energy and rotating machines. As such, Penn State has a great program. They have two small-scale turbines on campus. I think one's a 3 kilowatt, and then there's a 5 kilowatt machine. And after that, during grad school, I actually worked at Suzlon as an intern in Chicago. So, which was my real exposure to utility-scale wind in the U.S. After that, it was quite interesting. I was presenting at a WIA. And my research was based on optimizing small-scale turbines, what they call distributed wind. And I met the team from Merson, actually at a WIA, which is quite interesting. 4 years ago, I would think now. Yeah, that was back in 2015. And since then, it was a good fit. They were looking for someone hands-on, which I fit the role, and I've been with them since. And it's been a great journey so far.
That's excellent. So you're at Penn State. They've got a great aerospace program.
Yep.
Did you have to make a decision at any point to go either directly into wind or go elsewhere into rockets and other sectors of aerospace?
So it was quite interesting. They offered a range of rotating machinery science, but one of the most interesting things I found there was the icing chamber. They actually have a giant fridge with equipment donated by NASA to study icing on blades of rotating machines. Either it could be a chopper or it could be a wind turbine. Many wind turbines in cold regions face icing conditions and icing issues, loss of performance. So there was a big research program at that time and a push to understand icing of wind turbine blades. I found that pretty neat. They had some de-icing technology research. They had high-speed cameras that captured a blade spinning at 400 RPM, a section of a wind turbine blade. Obviously, a whole blade wouldn't fit in the fridge, but that was pretty neat. We captured icing mechanisms. We captured de-icing on the blade. And there's a wind tunnel where we put these ice blades and studied performance degradation. So that kind of led me to, further dig into deep science of wind turbines and so on and so forth, which then, of course, led to the internship, and then I was hooked, so to speak, from then. It's pretty cool.
So would you say that it's appropriate that you're a, quote unquote brush guy or a brush nerd? Obviously I know you're all at Merson, but
Yeah.
would you say that's your unofficial title then, is brush
Uh,
expert?
there's better experts than me. My manager, he's been in this industry for over a decade now. Um, and we have experts in our company who have been in the brush business, say, for 3 decades almost, technical roles. So for me, compared to 30 years, I have four. So I wouldn't say I'm fully an expert yet, but we learn as we go. There's new turbines out there. Trying to be hands-on, trying to get into every kind of turbine out there, learn about their systems, and trying to optimize and tweak them. There's so much we learn on the field, to be honest, and every week is you think you know everything, and then you find something new, and you're like, wow, even this is a possibility. So yeah, learning as we go, so to speak.
So we could talk about the technical side of brushes, but why don't we simplify it for the people out there that aren't the
Yeah,
wind turbine technicians or the engineers? For me, if you asked me, let's say 3 to 5 years ago, what is a brush in a wind turbine? I would have thought
yeah,
that they're giant toothbrushes that helped clean the inside of the nacelle, right? So I think
right.
there's a lot of people out there that have some
Yeah,
misconceptions about what brushes are and what role they play within the wind
right.
turbine itself. Could you walk us through just simply breaking down a brush and how it actually enables the power
Right.
transmission down tower?
So when you have a rotating machine, like a wind turbine or a textile mill, for example, it could be anything. Um, even if you have some high power tools, which are like drills and things like that, you need to move electricity from a stationary object to a rotating object. Now, in a generator or a wind turbine, that rotating object is at first the blade, which then rotates a shaft, which then rotates gearboxes, and at the end, there's a generator and the gen shaft. Now, if you generate electricity in a generator, how do you transfer it to cables and a transformer, which are obviously stationary, right? So this interface of a rotating part with a stationary part needs to have a sliding contact. So that sliding contact is a brush. Um, if you have the other way in which you need to transfer electricity from a power source into a shaft in order to rotate it, let's take an example of trains, where you have power generated, say, from coal or steam turbines, whatever it is, and you want to transfer this power into the wheels of a train. Obviously, you have a different commutation system there, but in general, there is a brush that acts as a sliding contact. The brush obviously is a consumable, so due to friction, since it slides, it does wear out. And that is the basic principle of what a brush does. Either take away energy from a generator or bring energy to a wheel or part that needs to rotate, so to speak. I hope that was clear enough or simple enough, and
Oh, it's
try to break it
fantastic.
down. Yeah, I
Yeah,
tried
it's
to break it down
fantastic.
as much as I could,
So can
but now,
you,
yeah,
without sharing the secret sauce, right? Could you tell us just a basic composition breakdown of what is
right,
actually in a brush? I think some people still might think, okay, it's bristles riding on a shaft, but
yeah.
maybe a
No.
little bit more.
That used that used to be the case and this technology goes back to the 60s, even 1800s, even. If you dig back into rotating machinery, rotating equipment, the 1800s is when all this began, and it used to be actual uh, bristles of metal, like metallic bristles, brushing up, sitting against a rotating disc. From that does exist today in very specific machines, but it's moved on to a block of carbon. So what starts off is carbon in a powdered form mixed with metals, mostly copper, and some sort of impregnation in terms of resins or there's all sorts of stuff that goes in there, which even I wouldn't know. So Merson's research and development is in France, and the secret sauce is actually in France. And it's almost like a recipe in a word. I have no idea. I couldn't tell you what to put in there. So, but the basics are it's carbon mixed with a portion of metal powders. These get mixed in. They need to be homogeneous, and then it's compressed into a block under high pressure. These blocks are then chopped and cut into the shape of the brush holder, and then obviously once the shape is obtained, they get the two cables, the shunts, what we call the shunts, and the terminals, and it's pretty much how you have a brush.
Yeah, it's fantastic.
Yeah.
So I want to move along to the history of Merson. So dating back to 1892, I think Merson
Yep.
was Le Carbone was the actual name of the
Yep.
company. That's correct in France.
Yes.
Obviously, you've been around for over 100 years. Kurz has been around for 100 years, but we've stayed pretty local in the Wisconsin area. If you had to dial it down to about 3 to 5 attributes of success that
Right.
directly contributed to the long-term growth of Merson, what would those be in your opinion?
So I can speak for the US market so far. From what I've experienced and the way I work and the way the team here in the US works is we always put the customer first. We are on almost like a 911 line for helping out any customer that needs help, be it on the engineering side, design side, field support, whatever it is. We have a team that's on the go. I personally travel 50%. There's new members on the team, wind technicians who are on the road 90%. My first 2 years here as well, I was on the road 90%. So that we try to keep it customer focused, and they see that customers do see value in that. Um, the second and important thing is we're not there just to be there. We do bring expertise. So years and decades of brush knowledge, is with this company, with the team here. I can tell you one of the technical managers who started off training everyone has been a brush expert for the past 25 years. So the technical expertise is really key that we bring it to the field, the training, the internal programs that we have. We try to stay up to date, and then we have constant back and forth between the R&D teams and the engineering teams and design teams to make sure we're at the forefront of this technology, to try to make sure we're ahead of the game. The third and the other thing is also we want to adapt. So any machine as it evolves with time, the requirements change, right? So with time, we have had to adapt to the turbines themselves. Since if you look at the sizes, if you go out to California, in the Tehachapi region or the San Gorgonio region, you can see the progression of wind energy. It's been quite interesting since the early 2000s. We've come a long way, and obviously, even though the brush is a small part in the turbine, it has had to evolve, and the whole brush system has had to evolve since 20 years ago, I would say, in a turbine specific context.
No, it's fantastic. Yeah,
Yeah.
California, anytime you take a trip out there, it is
Yeah.
so neat to see what are those 350 kilowatt machines?
Yeah, there's a hodgepodge. It's fun to be out there. They have some with two blades on them, and I don't know how they're still running, to be honest.
It's obviously great technicians.
Yeah,
Shout
yeah,
out to anybody in California
yeah.
who's working on
That's
those still.
fair enough. Yes, yes, sir.
Right on.
But they have,
Absolutely. And nowadays, just for the listeners, you can find onshore machines that are upwards of 3, 4, even 5 megawatts. I
yeah.
saw Enercon, which is, I believe, a European company, and
Mhm.
they've got a pretty decent holdover on that market. They have a
Yeah,
5 or 6 megawatt machine now for onshore wind,
yeah,
which is unbelievable to me,
yeah. They're getting bigger for sure.
which is awesome too. Per
Yeah,
tower, you're generating more energy, which obviously can be distributed to homes, businesses, and have a measurable impact on the community.
true.
Um, so people here listening, they might have some issues with their brushes. Maybe they're seeing
Right.
uneven wear. limited brush life, maybe just a couple years of brush life, maybe the performance isn't very strong, could see some grooving on their slip rings. Let's say they wanted to proceed and collect some data on the Merson brushes for their towers. What is a brush test, and what data do you actually look at to justify the investment to somebody who's actually looking to make a brush switch?
So we follow a very standard protocol. We essentially have protocols for testing, inspections, and upgrades. The problems you listed are very real. Everyone and anyone has seen some degree of it at their wind farm. If they've not, then of course they've been very lucky, and I'd like to go to those farms too. But in the grand scheme of things, there's a standard protocol for everything. We start off with first assessing what is the needed site. If you sometimes if you have a year running, years of life on the brushes, some sites are satisfied with that. They say, hey, if you can make it to the next annual cycle, we're good. Whereas some sites, if you go out there and they're getting 3 years and they're still up for, say, 5 or 6, we try to approach that as well and see what we can do to fine tune that system, right? You want to reduce the operational costs. That's goal number one, and increase reliability. So no surprises, no turbines down on Friday. I know everyone hates that, and so it's been evolving, and we've tried to iron out all these little wrinkles over time with the technology we bring. So we, as a customer approaches us saying, hey, we have problem A, B, and C, we might start with just C. Say, okay, let's try to fix this first, and give you 6 months of observation. We go out there, we climb with them, we actually train the techs to use the tools that we use, and there's so many things going on in that brush box. Not a lot of documentation out there actually speaks about the issues that can come up. There's a number of things that affect a brush running in that turbine. So we try to educate as well. We also have seminar series. We go to a central location and then invite anyone who's free for a 2-hour lunch session, and we do like a lunch and learn kind of a thing to educate everyone on how to better maintain, how to better clean, how to look for problems in their brush systems, and that's been helping quite a bit over the past 2 years. I think we did almost 7 or 8 seminars, and we've had attendance from 2 people per seminar to 45. So there's been a big range, and anyone who's interested is more than welcome. I think we did a few with Kurz as well, in collaboration with Kurz. That was great. And so there's that component of it, and then there's the follow-up is also key. So we do provide support to start analyzing the problems, the steps to fix them, and then we do keep going back. We do give follow-up support in terms of inspections, and then we do provide sound technical reporting to kind of explain to them, hey, listen, this is what we found, this is what you were looking for, and this is what we have fixed or addressed in terms of problems, and here's what you can expect from your machines in the future. And it's what I've been doing is I've been trying to make it a very, let's put it like a scientific method, in which we've been trying to make sure, if you get numbers on one machine, there's a way to duplicate that across the wind farm. So this way, if a technician is told, hey, this is what will happen in this machine on your turbine if you run it like this, they should be able to use that information and apply it to all 100 on the site, right? Then that's why the test is applicable. So we try to keep it as applied as possible, and we try to keep it as representative of the site as possible. So those are the few things, and all of it is listed in the protocol when we start off the project. So this way everyone has expectations lined up, there's no surprises, and the requirements at the end of the year are met. So in case someone says, well, we expected a 6-year life when we started this project, we don't want that sort of surprise to come up. So we do make sure everyone's clear on what the expectation is.
That's very good. And what
Yeah.
would you say are the three most common solutions that the site is looking for? Is it wear rate? Is it life of the
Yep.
brush?
Yep.
Could you maybe give me three just simple ones, rattle them off?
Yeah, so
Um,
you listed two of them, wear rates, lower wear rates. Everyone likes lower wear rates. They want the turbines to run cooler, obviously. So a lot of sites experience extreme environments, hot summers, cold winters. So they want their turbines to withstand those. They want the brush system to be able to handle that. And one of the other things is just simple reliability. They don't want any sort of strange brush behaviors, and they want to reduce costs. So we try to make sure the first if you address the brush wear, you just immediately address the second and the third almost, because if you have better brush wear, you probably are not running too hot, and you're also giving them the most bang for their buck in terms of purchasing the consumables. So if you address one or two of those, pretty much the sites are happy with the rest of it.
that's excellent. So
Yeah.
obviously you're doing great work today, and you're gathering all this data for different customers and wind sites. How do you
Yep.
foresee things changing in the future with the brush technology? We've already kind of talked about the
Yeah.
megawatt output of these new
Yeah.
turbines. Do you foresee brushes lasting longer, a brush that can last a decade instead of 5 years or 3 years? And overall, what's the vision of Merson that you can at least share with us?
For 10-year brush, then I don't know. I think we'd probably be out of business with a 10-year brush, but that's the dream, right?
Yeah.
One brush change in 2 decades. I think it's more complicated than that, because as if you got to keep in mind, as the turbine production numbers go up, the loads increase. So if you have higher loads, now you need more robust systems, which obviously, if you look into any design, um, like a design problem, the robustness is always correlated directly with the pricing, and so on and so forth. So if you start to increase the system's um, size and things like that, the pricing keeps going up. So we got to find that balance, and there's a lot of stuff going on. The buzzwords now are data and digitization and all that. So we're trying to keep up. As I said, one of the key things we try to do is try to keep up with the market. So we work obviously with the OEMs, whatever is set as a design, um, like a design requirement from the actual manufacturers of the turbines. We have to meet them, right? Um, otherwise as a company we wouldn't do well. So we work with a lot of OEMs. We have a bunch of OEM approvals, and they do approach us to work with them on newer technologies and so on and so forth. So that's pretty much what's going to be defining the future of this technology, is the design requirements, and we have to make sure we are uh, in line with the expectations, whatever they are. So
Interesting. So this is the last question before a rapid fire round. And I'm
okay.
actually throwing you a curveball here. So Neil and I sort of went through some questions together, but this just is a spur of the moment question. Feel free to decline if you don't want to answer. But
Yeah.
Kurz internally has been discussing the Internet of Things, right? The
Mhm.
connectivity to the cloud with all these different
Right.
technologies. How do you foresee brushes adopting that principle in just the overall brush system within a wind turbine?
Right, right. There's already some stuff out there. If you start Googling about it, uh, any system, mechanical or electrical, has to, keep up with the times and get on the IoT train. And I do see some, but there's so many challenges. You see, first of all, sensors. The sensors would need to be kind of dust resistant, because you have so many challenging. The environment in a slip ring compartment is challenging. So personally, I've thought about it quite a bit. Um, I'd love to have an app on my phone that would, help me know what's going on in a slip ring box before I even climb. That would be great. The ideas are out there. There's some technology out there. It's still nascent, but I think at some point or the other, it has to happen. The second point that, I've spoken about this with some technicians, engineers, and the question I get is, well, is it worth it? Because if you think of it, it adds a lot of cost, and once in 6 months you do have a person in that nacelle checking in on the brush box. So if you have a reliable enough brush in there, do you need to spend more money to make it a smart system? That's a debate. So I'll leave that debate to when there's more about IoT in the market.
Sure. No, it makes sense. And you talked about having a robust design, but that also
Yeah.
increases cost. The same principle probably applies here. Does the cost benefit analysis pan out to long-term profitability, especially when you have somebody going up tower every 6 months? So that's great.
Yeah.
I learned something new with this. I thought
Yeah.
that's the exact direction the market was going, but you opened my mind to something else. So I appreciate that.
Yeah. No, and that's how you not my mind. I was like, hey, wait a minute, this person is right. If we design something that's reliable, runs great for 6 months, there's a person up there checking on it at the 6 month mark. So it's a question.
Sure. All right, rapid fire round. You ready? 30 seconds or
Wow.
less.
I don't know what's in store, but sure, let's go ahead.
Keep it concise. All right. First one. What's your favorite part about going up tower?
The view. A lot of sites are in beautiful locations, so I look forward to just taking a peek out of the cell and checking out the view. That's quite. I don't think a lot of people have that opportunity. So,
Any state in particular that you're willing to share?
Oregon is beautiful, right by the Tri-Cities there. I've had some beautiful views in Texas as well. I've climbed a lot in Texas, and then up in around the upstate New York area. I've been there in fall, and the fall colors are just amazing to check out.
It's phenomenal. I got to get up there then.
Yeah.
I'll talk to Jay.
Yeah.
So you're from India. You
Yes.
came over. Well, first you went to Russia, which I just learned that today, and then you came to Penn State in the United States. Now living in New Jersey.
Yeah.
If there is one thing that you could bring back to the United States from home in India, what would that be?
Well, I'm from India, but I did grow up in the Middle East. So I spent most of my childhood in Qatar, actually, in Doha. It's a small country. So I've been all over a bit. One thing is there's a lot of good food here, Indian food, especially in New Jersey. But there's still, some things missing. So I think I'm spoiled because I've lived there and eaten local, but it's getting there. So in general, I think the food is what I would maybe improve a little bit.
Good. You took me to lunch when I was in New Jersey a couple
Yeah.
months back, and it was a phenomenal choice. So I'm going to definitely trust your judgment on the food aspect of this.
Yeah.
Moving along.
Yeah.
Go ahead. Go ahead.
No, I was saying I'm a foodie, so so I'm a little, a little picky when it comes to actual authentic food experiences. So that's pretty much the one thing that comes to mind first.
I think a lot of us who like to travel become foodies
Yeah,
organically. Got to find the right restaurants and the best places to
exactly.
eat. I get
Exactly.
it. So for somebody who is, let's say you're 16 years old, right, and you ended up becoming an aerospace engineer. Incredible. Let's put yourself in somebody else's shoes. They're 16 right now. They're in high school. They're doing exceptionally well with their grades. They're interested in getting into engineering. What sort of advice or tips would you give that younger individual to really accelerate their career?
So for me, it was, now that I think back, I was lucky because I was not pushed into one direction or the other. I was exposed to a lot of things. I was always like a hands-on guy, so I used to build things. And I think there's a lot of, right now, there's a lot of focus on, um, being hands-on, building stuff. And I would try to have everyone just get maybe like set the books aside for some time and just look at how to build things, how things work, take some things apart. Um, as an engineer, it might sound a little like cliche almost, but that's what helped me the most. And the other thing was kind of thinking outside the box. I just decided, hey, why the Russians went to space? They did a great job. Why not just try this out? And it worked out. So a lot of times, the kids are afraid to do something different. What if it doesn't work out? What if it fails? So I'd say like think out of the box and take things apart, and don't be afraid to just follow something. And if it doesn't work, it doesn't work. But hey, if you put your heart into it, it does work out. So that's the advice I would give.
So the synopsis: build stuff, really focus on creativity, and take some risk.
Yeah, pretty much. Just standard advice, I guess, for anyone in any field, not just technical. It's yeah, just think outside the box and go for it, pretty much.
Yeah, I love it. We're definitely going to be sharing this with a lot of our scholarship
Yeah,
applicants. Kurz has a scholarship that we offer now every year, and I
pretty
think it's
cool.
super important to be able to instill those values into anybody. It's always a nice reminder.
Yeah,
You say it's
yeah.
cliche, but I don't think a lot of people actually understand how important that truly is. Last bit about Merson. Neel, how can people find you? How can they interact with the Merson brand, Merson USA? And I know you got somebody knocking on your door, so
Yeah, well, thanks. Sorry
yeah.
about that. Oh,
Is this important? Do you need
yes,
it? Pedro needs it too, then, right?
yes.
And ladies and gentlemen, as you can see, the support never stops. While he's on the podcast, he's still working, so we appreciate
No,
that.
it's funny because we just renewed our climbing license, so I just got the ENSA card, uh,
Oh,
the climb training. Yeah, we just refreshed that. That was pretty cool.
congrats. Well, somebody out there needs to be the first person to give you a call and have you climb on your brand new license. This guy's newly certified. So, Merson, you've got a great web presence. I've seen you on LinkedIn. I've seen you on different platforms. How can people really interact, for lack of a better term, intimately with the Merson brand and get to know you guys?
LinkedIn's great. I use it heavily on their networking. It's a pretty neat tool. They have a lot of data and analytics and all that going on in the background. Also, I think there's an active Facebook page. We do have our French teams active on Facebook as well, and pretty much through you guys. Kurz has been a great partner for the years, and anyone who reaches out is if they reach out to you, I'm sure the message will come back to us, and you've been doing phenomenally well in terms of market outreach, and just even just catch us on the field. Even if if there's a word that hey, this is the brush guy, phone calls, emails, whatever is needed, we're always available to help out, send out technical info, help, and if need be, as I said, we go out there, we visit the farm, and that's always here to help.
Excellent. We're going to include all the contact information down below.
Okay.
As we get bigger with this podcast, we're going to make sure that this launches on iTunes, Spotify, SoundCloud. So we'll have that as a link in the show notes. And Neel, I just really appreciate the time today. It's been an excellent conversation. I've learned a ton, and I look forward to continuously learning alongside Merson.
No, thanks a lot, Dan, for having me here. It was a fun opportunity, something very new for me as well. I'm sure it's for Merson as well, and I'm looking forward to check out your sites. That's
Yeah,
awesome.
absolutely, Neel. And we'll see you at
Yeah.
a We in Houston.
See you in Houston. Yep.
Yes, thank you, sir. Appreciate the time.